Hi, my name is Dr. Pan from the Dawn Hearing Discovery Center. I'd like to talk to you today about the amazing event that is going to occur on August 21st, 2017. This will be the first eclipse seen by most of the United States since 1918. From the Pacific Northwest all the way to South Carolina, we'll see a total eclipse. Here in the Texas Panhandle, we will have a partial eclipse where you will see about 82% of the sun's disk covered. I'd like to introduce you to a number of definitions that are pertinent to solar eclipses. These include Umbra, which is the fully shaded inner area of a shadow cast by the moon during a total eclipse. Again, you'll only see the umbra in that area where you have totality, where you'll see the full total eclipse. What we will see here in the Texas Panhandle will be what's known as the penumbra. That's a shadow cast by the moon over an area experiencing a partial eclipse. All eclipses are special cases of a term called occultation, which is when one object passes in front of another object from the perspective of an observer. And the object that passes in front of that other object appears to be the same size or larger. Transit is a little bit different, and that's when one object passes in front of another object from the perspective of an observer, and that object that passes in front of the other object appears to be smaller. I'm here with Doppler Dave, and we're going to explain how a solar eclipse works. And it's very simple. It's basically when the new moon moves in the path between the sun and the earth.
So a new moon is when the moon is on the same side as the sun.
Absolutely.
Because when it's around on the opposite, that's when we get a full moon.
Exactly, and it's fully illuminated and you can see
the whole disk. But when it comes around to the same side, we usually don't see the moon.
Exactly, and so that's what causes that shadow, that umbra in the area of totality, and a penumbra.
Now, since we have a new moon every month, though, why don't we have a solar eclipse every month?
We have all of these objects basically spinning around each other and orbiting, and they don't orbit nicely. They kind of wobble. They're in different orientations and different angles.
So sometimes the moon is down a little bit, sometimes it's up, and it's rare to get that exact alignment to project a shadow into the Earth.
Exactly, and in fact, it's typically 5 degrees off of the elliptic tilt of the Earth.
We also hear about lunar eclipses, though.
That is on the other perspective where the Earth is blocking the direct sunlight.
So this would be more like a full moon, but when it crosses in, we have that same alignment. Now it's the Earth that's casting a shadow over to the moon and covering it up.
Exactly, but instead of having a darkened blackened moon, you actually get sort of what is sort of called a blood moon. It's sort of red, and that's because you actually have scattering of blue light rays, and so all you're getting back you're seeing are these red light waves.
What kind of copper colors?
Exactly.
Okay, but on August 21st, we're going to have this alignment right here where the moon actually crosses in front and obscures the sun.
Absolutely, and that's again because we're amazed because it's right here in the northern hemisphere. Around 4.5 billion years ago, you had a large number of planetary bodies forming around the sun, and these included things like proto-Mercury, proto-Venus, proto-Earth. But you also had some things that sort of had these irregular orbits. It is hypothesized that a Mars-sized protoplanet cleaved and hit the Earth around 4.5 billion years ago and took off a portion of the Earth's crust and mantle and flung that out into space. Because of the gravitational pull of the Earth, that slowly began to form a ring around the Earth, and that formed into our moon. What's really great and amazing about total eclipses is that we, in our solar system, we're the only rocky planet that actually experiences total eclipses. Now, that doesn't mean that other planets in our solar system don't experience eclipses. Some of them do, and even things like gas giants experience total eclipses. But if you're going to talk about a planet whose geology is made up of rock, we are the only planet that actually gets that. If you take a look at this image right here, which is not to scale, you'll notice a few things. One, Mercury does not have a moon, and so it's been impossible for it to have to experience a total eclipse because there is no moon to block out the rays from the sun. The same goes for Venus, in which case there are no moons, and so they don't experience a total eclipse. We have Earth, which we've been talking about, but let's go to Mars for a second. Mars is very interesting in that it does not experience total eclipses, even though it has 2 moons. Deimos and Phobos are very interesting. They're small, rocky. They're actually very regular in shape because they're very small, but because they are so small, they cannot block out the full disk of the sun. So one of the really interesting reasons of why Earth is the only rocky planet that can actually have a total eclipse is because of the size of our moon, which is pretty large in proportion to the planet itself, and also because of how close the moon is to the Earth. If someone were to look at Pluto, Pluto is a very, very small dwarf planet, and Charon is actually quite large in proportion to Pluto, as you can see from this image right here. What's really interesting about Pluto is that every 120 years, Pluto experiences a total eclipse every 6 days. And that's because of how large Charon is and then how it is tidally locked with it. Again, one of the most important things to experience a total eclipse is to have a large-sized satellite or moon that can cover the disk of the sun in proportion to the object that it's covering. While again, Earth is the only rocky planet in our solar system that experiences a total eclipse, our gas giants can actually experience total eclipses as well. And that is also because they have several moons, and so they can actually have some really cool things happen. Jupiter has many, many moons, and particularly its 4 largest moons are known to cause total eclipses. Right here is an image of Jupiter showing 3 total eclipses occurring on the northern hemisphere of Jupiter all at the same time. These are caused by Io, Callisto, and Ganymede. Saturn is also known to have total eclipses. If you look at this image right here showing the total eclipse of the southern hemisphere of Saturn by Titan.
Well, we're joined here with Mandy from the Discovery Center, and she's going to help show us a way that we could view the eclipse if you don't have eclipse glasses without hurting your eyes, because that's the main thing when it comes to eclipses. You can't look right at it. So what do you have here for us?
Okay, so there's actually 2 different ways you can do this. There's a more complicated version that I actually pre-made just to kind of show you today. So basically all you need is a box. If you got a cardboard box at home or something easy, and then all you have to do is you're going to poke a tiny little hole in one end, and then on the bottom you're going to want to cut out a little slit because that's what you're going to look in. And then when you go outside during the solar eclipse, you're just going to hold this up, let the sun shine through that little bitty hole, and then you're going to look in the little viewer underneath, and on the other end is where you're going to see the solar eclipse. And the cool thing about this one is you can make it as long as you want. The longer you make it, the bigger the eclipse is going to get, which is kind of cool. So this is the more complicated version. Now I'm going to have you help me make a really simplified version.
All right, this will be perfect. So again, if you don't have your eclipse glasses, you can just make one of these. It's always so fun to make one.
Yeah, it's just fun to make one at home, and you can even, like, if you want to decorate and color it, that makes it even cooler. So what we're going to do is you're just going to fold it in half, and this is cardstock, by the way. You're going to want a little thicker paper. You can do it with regular paper, but cardstock is nice. So what we're going to do is we're just going to cut a little square out of the middle here, and I'll cut one, and then I'll let you cut yours. So we need somewhere to put our aluminum foil, because the aluminum foil is what we're going to actually poke our little hole with. So if you want to cut a square, so if you've got a nice little square out of the middle, it doesn't matter what size the square is, just, decent size. And now what I'm going to do is get some aluminum foil. Perfect. See, you're a pro. All right, so then all you got to do is cover up your square with some aluminum foil.
And why is it important that we make these and don't look right at the sun?
All right, so that's a great question. Even though the solar eclipse is going to be really, really cool, you don't want to look at the sun just because that's going to hurt your eyes. I mean, just like on a regular day, if you go outside and look up at the sun, do not do that. I don't recommend it. It's going to hurt your eyes. And so, and normally people don't do that, but for whatever reason during the solar eclipse, it's very tempting, to stare up there and watch. But we don't want you to do that. We definitely want you to be safe and have an alternative way to look at the sun, which you can go buy glasses if you want to go get the solar eclipse glasses. Make sure they're the right ones, they're certified, and you can use those. But this is just kind of a fun craft. You can do it with your family, get a whole bunch of friends involved,
I mean, and it obviously takes no time to make this. I mean, we made this here in just a couple minutes, and
yeah, done. And so the only other thing you've got to do is you're going to need a paper clip. So what you want to do is kind of poke the smallest hole you can into your aluminum foil. And so you just poke a nice little hole down in the small, teeny tiny little hole. And then what you'll do when the solar eclipse happens, you'll go outside and you're just going to hold this one out. Okay. The sun is going to shine through that little pinhole, and it's actually the solar eclipse will end up on the ground. So go grab something white, piece of paper or something, just to put on the ground because it'll be easier to see it. But then you just hold this up and you just watch the whole thing happen below instead of having to stare at the sun.
That is really cool.
Yeah, the other neat thing about these too is you can actually poke a bunch of holes, and if you do that, then you'll see the solar eclipse from different angles, and so you'll have more than one down on the ground too.
Oh, neat. Okay, that is really cool. Yeah, so I mean, this is obviously super, super simple to do. That one's a little bit more complicated, but I'm sure even that, if you have a box or you make a box, it still won't take that much time. I mean, if it means hurting your eyes or looking at it safely, I think that it's
Right,
worth the
exactly.
time.
Definitely take the time, make something simple, and hopefully you've got materials like this at home that you could just, you know, grab out of the kitchen and whatnot.
Now, I don't know if this will work, but if you had thinner paper, could you maybe stack the paper? Is that something that would
You really
work?
could.
Yeah.
Yeah, you could stack the paper, and really too, aluminum foil is just more of a safe method, so you don't have to use like a push pin or something sharper to make your hole. So you could really even just get a regular piece of paper, just thick, stack it so you don't want the sun going through it, you know, but stack it together and then just poke you a nice little hole. Yeah.
Great. Well, this is super easy, so definitely a fun activity that you can do to safely view the eclipse, and that's coming up before we know it, so definitely going to be a lot of fun.
Awesome. Thank you.